Let's take a look at a worker role. A worker role is a .NET 3.5 Service Pack 1 or 4.0 service component that are typically used for things such as long-running tasks that are asynchronous that the user does not have to wait for. You can also host application services that do not require user interface. You can also have a background services listening to a queue. A worker role can also be used to run TCP-based services or even be used to compute intensive jobs. Keep in mind, though, that worker roles by default do not allow inbound connections. A role is similar to a Windows service. While it inherits the role entry point as part of Windows Azure, it also has the same structure that a Windows service has, such as OnStart and OnStop. It gets started once deployed and will get stopped when required. For example, it could get stopped because you are redeploying to a different server, or you actioned the stop from the web portal. A worker role is called by the Fabric on startup, which initiates the OnStart method, allowing you to perform any initialization tasks you need to perform. The OnStart method also reports busy status to the load balancer until you return true. The run method is where your main logic goes. It should never have any code in this method that exits the method. The purpose of this method is to continue running, such as continuously polling for a message. The OnStop method is called when the role is shutting down or is to be shut down. This is where you would do any garbage collection and gracefully, the keyword here being gracefully, exit. As a quick side note, it's up to you to keep running and never return from start unless you have been told to do so. You do not need to handle the stop. You can simply fail if you need to. There are three common patterns of worker roles. Pattern 1 is for polling. Worker role polls a queue and pop messages, it performs work, and pulls the queue again. For example, you can use it to pull background and process background images. Pattern 2 is a listening type pattern. The worker role listens for inbound TCP requests. For example, you can implement a raw TCP listener or use WCF services or use a hosted web core. Pattern 3 is an external process pattern. In this pattern, you can run a third-party process in the OnStart or run methods. When the role starts up or runs, you would use a process.start call to run a standard Windows executable, such as running a database server. So with that, let's take a look at creating a worker role. So just like we did with the web role, let's fire up an instance of Microsoft Visual Studio 2010, and let's create a new project. Like a web role, we want to select the cloud template, and let's keep the name as is, and let's double-click the Windows Azure Project template. When the new Windows Azure Project dialog comes up, we want to select the worker role template. So go ahead and double-click that. And let's change that to worker role demo, and click OK. Visual Studio will now create a new solution, and this solution will contain two projects. There's our Windows Azure project, and there's our worker role. Notice that the Windows Azure project references our worker role. It also contains a configuration file that defines the model for our Windows Azure solution. Like we talked about, our worker role has a run method and an OnStart method. We're going to ignore the OnStart method and put most of our code in the run method. And in this example, we're going to write some code that will pull messages from our Windows Azure Storage queue. We haven't really created our Azure Storage account yet, so we don't have access to the queue, but the code we're going to write will certainly illustrate the worker role functionality that we have been talking about. The code that we need is pretty simple, but I'm going to get the beginning part of my code from a text file I have, so let me go grab that. I have a code document on my desktop. I need these 3 lines of code. I'm going to go grab those. Go back to my run method. And right before the while loop, I'm going to paste these 3 lines of code in. Now, we'll talk more about these when we talk about queues. But the first line of code initiates and creates an instance of our cloud storage account. We get an instance of the Cloud Queue client. Then we can get an instance to a specific queue. Now what I want to do is modify the while loop. In my while loop, instead of sleeping at the beginning, I want to grab and start pulling messages off the queue that I've defined up here. So I'm going to write the following code. Say cloud queue message, and define an instance of a new message, and get the messages off the queue. I then want to look to see if the message I pulled out is actually valid. So I said if message is not null, then I want to process that message. So I may want to do something with this message. So I'm going to say string the message equals message dot as string. Very simple example here. Then I may want to do some work, so whatever that work is. And then when I'm done, I want to delete that message. However, if the message is null, or meaning there was no message to pull off the queue, here is where I want to sleep. So I'm going to indent these a little bit, close that, and sleep. So here's an example where I might use a worker role to pull messages off the queue. And in this example we talked about, it doesn't specifically exit, it continually runs. It looks like I messed something up. Instead of .end message, this should be .get message. And there you go. There you have it. So let's take a look at the final role type, which is the VM role. A VM role lets you run an image of a Windows Server 2008 R2 virtual image in Azure. The virtual hard drive is created on-premise using a Windows Server machine. Then that image is uploaded to Windows Azure. With a virtual machine role, you are responsible for configuring and maintaining that image, such as the operating system and any licenses. However, you do have more control over the image and can use items such as Windows services and scheduled tasks, including the ability to reboot and reimage, as well as remote desktop into the image. Once the image is stored in the cloud, it can be loaded on demand into a VM role and executed. This image can also be used as the base image for all instances of a VM role. As part of the VM role, the image can benefit from many of the Windows Azure automated management services. Using a VM role is a multi-step process, beginning with the creation of your base image. You then need to create your service, upload your image into a blob, and then deploy your image. Once the image is deployed, you can maintain that service, remote desktop into that image, and you can upgrade that service at any time with a new OS image. There are a lot of questions surrounding the VM role, and these next few slides will address the common questions we see as we talk with customers. One of the biggest misconceptions is in regards to durability. Your image is not durable, meaning if for any reason there is a hardware failure or a recycle of the base OS, your image is lost. Does Windows Azure take care of everything? Unlike a web or worker role, with a VM role, you are responsible for creating and maintaining the operating system. This includes any licenses, such as Windows and SQL Server, and just as important, Azure does not automatically understand the health of any applications running in your VM. However, since you deploy services instead of individual virtual machines, Windows Azure does automate many of the management tasks. So, how will the virtual machine role be priced? Currently, it is priced the same as the web and worker roles, being charged at an hourly rate depending on the compute instance size. From a licensing point of view, licensing for the virtual machine role is included in the compute hour price and is not related to the licensing status of the installation media that was used to create the base image. Any applications running on the image are licensed per the terms of the application. In the context of a VM role, an instance is a physical implementation of your image. Windows Azure provides different sizes of instances, but when running multiple instances, they all need to be the same size, and you cannot change an instance size on the fly. Instance sizes range from extra small to extra large, with each size differing in the number of CPU cores and the memory available to you for that instance. So with that, let's take a look at creating and uploading a VM role. So in this example, I'm going to illustrate how to upload a VM into Windows Azure. Now, I'm not going to bore you with all the steps on how to create the VM. I'm going to assume you already know how to do that and have done that. But I am going to illustrate and walk you through installing some important additional components that you need to add to your VM prior to uploading it into Windows Azure. So to get started, I'm going to remote desktop into a Windows Server 2008 R2 box. So I'm going to connect there. And this is the box that I created my VM on. So let me get rid of these additional boxes. This is my Windows Server 2008 R2 box, and this is the box that I have a Hyper-V created on. So I'm going to go into my Hyper-V Manager, and I've already created my virtual machine. Let me resize this real quick. Now, what we need to do to our virtual machine is to install the Windows Azure integration components. And these components are actually installed as part of the Windows Azure SDK. So I've already installed that on this box, and it's located here in Program Files, Windows Azure SDK 1.4 in the ISO. And when you install the Windows Azure SDK, you get this Windows Azure VM role ISO. And this is what we need to mount to our virtual machine. The way you do that is on the properties or settings of your virtual machine. So let me select our virtual machine and select Settings. And in the Settings dialog for our specific virtual machine, we simply select the DVD drive of our virtual machine. And I've already done this, so it's already in there. But we specify in our media the path to this ISO that we just looked at, because what happens is when we boot up our virtual machine, it's going to mount this ISO as a DVD drive. So let's quickly run this and take a quick look. So I'm going to make sure my VM is selected, and we'll click Start. That's running, so we'll connect to that. And let's resize this just a tad so that we'll make it more visible for us. I'll resize that. There's our VM. Let's log into our VM. All right, so there's our VM. We've just booted and logged into our VM. So let's go into the computer and look at the contents of that ISO, because when we booted up, we said boot up with this ISO mounted as our DVD drive. Here it did that. So we can right mouse click on our DVD and select Open. And you notice that it has 3 files on the DVD, and what we need to install is the Windows Azure integration components for 64-bit, because that's what we're running. I've already done this, but the purpose of illustrating this was to simply show you that you need to be sure to install these components on your VM prior to uploading it into Windows Azure. And this was the steps on how to do that. So I've already installed it. We don't need to do that. So let's shut things down here real quick. Let's shut down the VM. And let's force the shutdown. All right, our VM is shut down. We can close our Hyper-V Manager and disconnect from our RDP session. So my VM's all ready to go, and I've copied that to my temp directory here. There's my VHD. I'm actually going to get rid of that file. So there's my virtual hard drive that's already been prepped. It's got the Windows Azure integration components on there, and it's ready to upload into Windows Azure. However, we still have a few more steps that we need to do. They're very simple, but a few more steps that we need to do prior to uploading our virtual hard drive or our VM into Windows Azure. So, first thing we need to do is to create a certificate. And the certificate, anytime that we're dealing with Windows Azure and uploading into Windows Azure for security reasons, especially a VM, is we need a certificate that we can add to our Windows portal, because that's what we're going to use to upload our VM. So, to do that, we're simply going to use the DOS command that's called make cert and simply create a certificate that we can add to our Azure portal. So we're going to go into Visual Studio 2010, into the Visual Studio Tools, and start the Visual Studio command prompt as an administrator. And here simply we're going to go to the directory where we want to create the certificate, in our temp directory. And here we're going to use the make cert, again, the make cert command to create a certificate. And this is simple as typing the following to create our certificate. So we're going to say make cert. And we're going to give our certificate. The certificate name is going to be call it appdevvm.crt. PE-A. We're going to use the SHA encryption with a length of 2048. And again, we're just going to say, call it appdevvm.cer. Oh, I just blew that. So let's type that again. I just blew that by up arrowing. Make. And the reason I up arrowed is I wanted to make a change on the line because there's an error on my typing on the line. So let's do this real quick again. -R-N. Call this CN equals appdevvm, call appdevvm cert.cer. Then we'll say -PE-A. Again, use the SHA encryption with a length of 2048. And again, appdevvm cert.cer. Okay, so this is just going to create our certificate that we're going to load into our Windows Azure portal. All done. So we can go into our temp directory. See the cert right there. So I've created our cert. Now we can actually go and create another cert if we wanted to, because this cert is just to provide the security for uploading our VM. We could create another PFX type of certificate if we want to actually remote desktop into our VM once it's uploaded, but we'll save that for another time. We're done with this. So to add our certificate, let's go into our management portal and select our hosted services node, and let's add a certificate. Oh, let's fix this. Let's sign out and log back in real quick. All right. Everything's loaded. Let's go into our management certificates. Let's add a certificate. We're going to add it to the subscription. Let's browse for that certificate, and it's in our temp directory. Actually, that we just created two certs of the same name, so I'm actually going to go and delete one. We actually had a certificate of that name. And I want this cert that already exists is we used in another demo, and I don't want to use this one, so I'm actually going to go back and create a whole nother cert that we're going to use specifically for uploading our VM. Let's do that one more time really quick. All right, so let's go back into Microsoft Visual Studio 2010, the tools, the command prompt, run that as administrator. All right, let's just do this real fast. CD temp, we're going to create it there. Before we go any further, let's delete the one we created and do this really fast. So make cert say, and we'll give it a different name this time that's different from the one that's already in there. So we'll say app dev. Let's call it app dev for now. Again, give it a length of 2048. Everyone, actually, we need to .cer, and same thing, appdev.cer. There we go. There's our cert. We're going to keep that window up. Let's add that certificate. There it is. Okay, so there's our new certificate, and we're going to use that to upload. What we're going to be using from this later is this thumbprint. Okay, so we've created our certificate. We're almost done. We've got our certificate. We've uploaded it into our Windows Azure portal. The next thing we need to do, though, is actually we're ready to upload our VM. And the upload process is really a two-step process. So we're going to get rid of this DOS command. And what we need to do now is we need to open another DOS command, but we're going to open it from the Windows Azure SDK. So we're going to open Windows Azure SDK command prompt as administrator again. And again, we're going to go to the location of where our virtual hard drive and our VM and our certificate are. We don't need to do anything with our certificate anymore, but we are now going to upload our virtual machine. So here's what we're going to do. This is really a two-step process. The first thing we need to do is actually create a connection through this command prompt up into the location of where we want to upload our VM. So to do this, we're going to use a command called the CS Upload command line tool. This tool is really used to upload virtual hard drive image files to Windows Azure and to set relationships among these images. But we're only going to upload one, so we're just going to use this to upload our image. So the way this works is the following. We're going to execute two statements. What we need to keep in mind here is that if we execute the first statement and then close the command window and then open another command window to upload, it's going to say, no, you can't do that because the connection hasn't been established. So kind of like a session thing. We need to do both statements within the same command window. And so the first thing we need to do is establish our connection. And this is simply by specifying the subscription ID and the thumbprint of the certificate that we're going to use. So we just simply say CS upload, set the connection, and we're simply going to pass the subscription ID and the certificate thumbprint of the certificate we just uploaded. And so we can get that really from this location. So here is our subscription ID. We'll copy that to the clipboard and then paste that right here. So there is our subscription ID. And now let's go back and get our thumbprint. And we'll paste that right. Whoop. Didn't quite get it. Let's try that again. I know what's going on. I've got it in the clipboard. I need to do it this way. Edit, paste. There we go. So we have our subscription and our certificate thumbprint. So let's hit enter. There we go. Our connection has been defined. So you notice that it says updated the default connection string. So it's ready now to, it's established that connection. We're ready to upload our VM. So really the moment you've all been waiting for. So let's, really we're going to use the same command, the CS upload command, to upload our VM, and this is a little different. We need to specify the path to the VM and the location where we want to upload to, and then the name of the VM once it's uploaded. And so let's simply say CS upload. We're going to add a VM image. Let's move our mouse so we can see what we're typing. And then we have to specify a literal path. And since we're doing this from the directory of where VM resides, we don't have to specify the entire path. We can just specify the name of the VM and the location. Now the location refers to really the geolocation of where we want to upload that to. So in this case, we're going to specify North Central US, right? Because that's where we're going to upload the VM to. Since that's where we have our subscription already defined, it makes sense that we're going to upload it there. And then lastly, just the name of what we're going to call. So we're just going to call this app dev VM. Let's call it, let's name it something a little different. Well, no, we'll keep it that, app dev VM.vhd. Alrighty, so we're ready to go. We've defined where the image, where the location of where it's going to go, and the name of the VM. So we're ready to go. Cross your fingers. We'll hit enter. So great. You notice that it's using the saved connection string. And we get a message that says the virtual hard drive will be mounted for further verification. You're going to get this prompt. Go ahead and click OK to continue. So you notice that, oh, we got an error. So the error we received basically says that it failed the verification test. We're not sure why it failed the verification test, but we can bypass that and simply upload the VM. And it could be that it failed the verification test because the VM was created on one machine, it was copied over to another one, it may not be matching or something like that, who knows. The key here is that it failed the verification test, but we can bypass that during the upload process, and we can simply just specify, say, skip verify. So let's try that and see what happens. All right, making progress. Now this could take a while, again, because our virtual hard drive is actually 15 gigs, so we're going to be loading 15 gig up into the cloud. So what we're going to do is we're going to come back when this is all done and go from there. Alright, so the upload is finished, and as you can see, it says that it created a new page blob of size, some large size. It tells you the elapsed time of how long it took to upload, and then gives us some certain information about the upload. So there's the name, the label, the description we gave it, and some IDs and timestamps and sizes and things like that. But the key that we want to look at in there is the status, and it says committed. And we've spent a lot of time in the portal, and by now that you know if things are ready to go, they'll say ready. But this says committed. So we're actually going to, let's exit our command prompt and go to the next step because it says committed, but it's not ready. And we need it to be ready. So let's exit this. And let's actually refresh our portal page. And we'll select our hosted services node. And where we want to look right now is in the VM images. So you'll see over here in the VM, there's the VM it uploaded. It uploaded successfully. It's active, but it's committed. It's not ready. We really can't do anything with it yet. It's committed. So we need to do the next step, which is to create and deploy the VM role service models, the configuration files in the actual service role. So that's our next step. So the way to do that is we're going to create a whole new Visual Studio project, and which defines the role information, and upload that as well. So let's minimize this, and let's fire up Microsoft Visual Studio again, and we'll run that as administrator. And we're going to create a new project, and again it's going to be another cloud project, and we're just going to call this VM admin. Click OK. Now here we don't need to do anything. We can just click OK here because we don't have the option to create a VM role type. So we're just going to click OK here. And in our roles, we need to right mouse click and select Add. Now, I'm walking through this because the role type that we want to add is actually a VM role type project, but we don't have one. So how do you get that? So the way you get that is we're going to save this and close our project, because when you went in and signed up for the beta program for the VM role, you should have received an email with a link to an additional install that gives you that new menu item. So I have that link, so we're just going to type that link in and download that new component real quick. So that component actually is, we're just going to type it in. So go to Microsoft.com/FW-link. And then pass it the link ID. So link ID, and it's not that one. It is 206860. Now this is for the 64-bit, and there's a link in your email for the 32-bit. But all this does is just download a quick reg file that enables some entries in your registry, or adds some entries into your registry. Go ahead and save that. Save that into my temp directory. And we'll close this and go back to our temp directory. And we'll just run this. And it's saying, do you want to verify the publisher? Go ahead and click Run. Run that. Say yes. And it's going to say, hey, this unintentionally change or delete values, but yes, we want to run this. It says you're good to go. We'll click OK. Let's go back into Microsoft Visual Studio. Again, as administrator. All right, so let's open our VM admin project again. Now if we go back to our solution, right mouse click on roles and add, we see that we have a new virtual machine role option here. So we'll go ahead and click that. Now the first thing we need to do is create some credentials for this, because this is going to be a whole new project. So what we're going to do is we're going to say add. We're going to create a whole new certificate for this. So we could use one of these, but we're going to just click create, and we're going to call this, let's make sure, let's see what kind of certs we have already. So we're just going to call this VM cert. Okay. Now what we need to do is, in step 2 of this, is we need to copy the full path of that to our clipboard and actually add that to the portal. But what we also need from here is our subscription ID. So let's go grab our subscription ID. We can get that from anywhere, really. So we'll find that somewhere. Yep. Okay, so there's our subscription ID. We're going to grab that. I'm going to paste that here, actually. And then we're going to copy the full path of the certificate. And then we're going to go back into our Azure portal and add that. So we're just going to go into Management Certificates. We're going to add a certificate. We can actually browse to that. We can actually paste that up in here. Let's get rid of that. There's our VM cert. I'm going to click OK. There's our cert. So we can go back into here and we can click OK. Wonderful. So the next step is to select a virtual hard drive for the virtual machine role. There it is. It picked that up. And we've selected that. And so we can go ahead and save this. Now at this point, go look at our service configuration and service definition files. So if we look at our service configuration, we can see that it contains the following information for the VM right there. And if we look at our service definition, we can see that it added that to our name of our VM role plus some diagnostics information. So it did add that information to our service definition and our service configuration files. Now back on our configuration page, we're actually going to change our instance count to 2. We're going to leave that as small because when we initially created our VM, we created it as a small instance, and really that means it's, we mounted our VH drive as a 35 gigabyte, and that's what it is, so that's a small instance. So let's save our changes again. And the next step is we're going to add an endpoint. We're going to add an additional endpoint. We're just going to call it endpoint 1. We're going to keep it a TCP, and we're going to just give it a port number of 8000. And you'll notice that it added this to our service definition file right there. All right, at this point we're done. So we can actually build our solution. And like everything else, since this is a VM role, we actually need to create a new role in our Azure portal and then upload this like we've done with everything else into the Windows Azure portal. So we're going to publish, and like everything else, it's going to create a service configuration and service package and configuration file. All right, so now we just need to go back to our services page and create a whole new service. We're going to say new hosted service. And we're going to give this a name. And we'll call this hosted, we'll call this AppDev hosted VM. That should be good. We're going to deploy right to production, and we're obviously going to select the North Central US region. We'll give this a deployment of V1. Now let's go back and grab our location here, and we will browse for both the this is the service configuration, and the package. We've already added their certificates, so we're good to go. We'll click OK. We'll upload that, and that's going to prepare this. So it'll take a few minutes. All right, so the VM role is all ready to go. We've uploaded. We have our 2 instances, and it says we're ready to go. So realistically, what we should be able to do is now go back over to our VM images and see that it's ready to go and be able to work with it. So let's do that. Let's go over to our VM images. Let's actually refresh this page. And then we'll drill back down into that. Just go in there. So we can see now that prior to uploading our role, when we looked at this last time, it said committed, but the in-use property said false, so it wasn't really ready to go. Now that we have actually created and deployed the VM role service model, you notice that it has changed the actual property of in-use to true. It is ready to go. If we uploaded a whole new certificate, we could actually RDP into this. So at this point, our VM is ready to go. Okay, in this example, we created a VM and uploaded that VM into Windows Azure. We then created the associated VM role service model, which now gives us the ability to work with the VM and use it. Now, after all of this work, you might be asking yourself, why would you want to use a VM role? Well, it allows us to run different types of applications that Azure doesn't support, such as WinForm applications or older legacy applications, such as old COM applications, yet still take advantage of most of the benefits of Windows Azure. The downside to running a VM is that you are responsible for the OS, the maintenance, any upgrades, and are still responsible for any software licenses such as the OS or SQL Server if you're putting SQL Server on the VM. However, VM roles do provide great flexibility if you want more control over your environment. Now from here you could add some web roles or worker roles that can interact with a VM, and by adding the remote desktop configuration during deployment and the associated certificate, you could RDP into the VM.